Hello everybody, I'm Nick, and in this video I'm going to show you how .NET 8 finally allows you to easily fix one of the biggest issues with using an immutable array in C#. And if you've never used an immutable array, then I'm a bit worried about that, because you should be using the right data type for the functionality that you might need in your application. So if you're using array for everything, or list for everything, or maybe even enumerable for everything, then you might be using the wrong type. You should be using the right type for the right job. An immutable array can be the right type for the job of providing an immutable array, i.e. an array that cannot be mutated. In this video, I'm going to show you what the problem is, how you could technically fix it in a pretty hacky way before .NET 8, and how .NET 8 makes it very, very easy to fix. If you like that type of content and you want to see more, make sure you subscribe, and for more training, check out my courses on dometrain.com. Now, before I move on, I'd like to let you know that I just launched my brand new course from zero to hero logging in .NET on dometrain.com. Now, I'm extremely proud of this because logging is such a fundamental of every .NET application, no matter what type of application it is, whether that's a desktop app, an API, a web app, a game, anything can have logging in it. And it's also a cross-cutting concern, meaning that it can actually cut through any type of layers that you might have in your application. It is super important to have mastery over it, especially with modern tooling, and this course achieves that. We start from some very basics, assuming that you don't really know much about logging, into some deep dives, into some more advanced features, and then we end up covering all of the advanced features and also some high performance features. And then on top of that, because I know how important it is and how much it is used, I have a dedicated section on Serilog, a third-party library for logging that most companies out there is using, so you can have mastery over that as well. Now, to celebrate the launch, I'm offering the first 400 of you a massive 20% discount code. So go at checkout and use log20 to claim a 20% discount code at your purchase. Again, that's for the first 400 of you, and they do tend to go quickly. So I hope you enjoy the course, and now back to the video. Okay, let me show you what I have here. So I have this program.cs over here, and I have this faker class and this user object. All this user has is just a full name, and that is it. Now, if I go back over here, as you can see, I am generating 10 users, and I provide the specific rule for that user. All this really does is it's using a library called Bogus, which allows me to generate realistic looking fake data in C# to generate 10 random users with realistic looking full names. So if, for example, I say users.forEach and I print everything in the console, so I say user.fullname, and I just run this, then as you're gonna see, I'm gonna get 10 names that look realistic, and if I keep running it, it's going to be new ones and new ones every single time. Very convenient if you want to just test things around. Now, let me show you what the problem is. I have an array of users over here, and assume that this array of users is just internal to whatever I'm doing. So if I'm using this within the context of a library and I'm shipping that library to other users, or even internally to me, but I don't want to be mutated, then what you might assume you should be doing is say immutable users is users.toImmutable array. And that will be a fair assumption, because this would actually allow you to use the immutable array type of that specific user type. The benefit of this, of course, is that now these immutable users that you might be exposing publicly cannot actually be mutated. Not the users themselves, so you can still mutate the users. So you could say something like full name is Nick Chapsas here. However, you would not be able to say remove a user and mutate that original array from behind the scenes. This is because immutable types in C#, yes, they do allow you to say remove, add range, and so on, but they don't actually mutate that array here. They actually return a whole new one, which can be a pretty inefficient operation, and you should stay away from it if you can. Something very important you have to know, however, is that any method in any collection that starts with to, so for example, to dictionary, to array, to list, to anything, will actually generate a new collection of that type you're requesting. So what is going to happen here is we're going to reallocate a new array, and that array will contain the values that we have here. This allocation is pretty expensive. That, however, is a necessary evil, because if you have to ship an immutable array to some other parts of your application, then you sort of have to use it. Now, just to put everything into context, I'm going to show you how this performs on its own. And to do that, I'm going to run a benchmark. So here is my benchmark class. So as you can see, I have an array of users, and I have just 100 of them. And I generate all of them with a seed, meaning they're going to be deterministically random. So between test executions, I'm going to generate the same sequence of fake names to have good, consistent results. And then I'm just going to say to immutable array and see what memory we allocate and how long that takes. And we're going to do that actually with 100, but also with 10,000, just to see the scaling between 100 and 10,000. So with that in place, I'm going to quickly say return early over here and then benchmark runner.run benchmarks, and that is it. So let's change this to release mode and let's run it and see how that performs. All right, so results are back. Let's see what we have here. So as you can see, 100 items, 55 nanoseconds and 824 bytes of memory, and then 10,000 items, 2.7 microseconds and 80 kilobytes of memory. So memory actually does scale as expected, but speed is a bit different. Now that is fine. You'd sort of expect that, and we don't really need to go in details why the speed is scaling that way. But let's assume the following. What if all I actually have over here is an array that I know nobody else has access to? Only I have access to that. And I want to provide sort of a view of that array as an immutable array. But I don't want to have to reallocate everything. I want to be efficient with my memory and my speed. So I'm just going to sort of wrap it and provide it to the user. Well, you might assume that maybe you can do that by using an immutable array of user and then passing the users down. However, you can't do that. And the reason why you cannot do that is because that constructor, which by the way does exist, is actually internal. So you can actually see it here. This is the constructor I was referring to. So technically it would be possible, but it is not. And it's also a pretty dangerous operation if you're not very careful in terms of who actually has access to that original array. Because if you do that and then change that original array, then the immutable array also changes. So this use case is only valid if you know for a fact that you own that array and nobody else has access to it, and you want to provide a very efficient immutable array view over it. Now, even though that is not possible, here's what is possible. Let's say I want to provide that same immutable array of users. To do that, you would say unsafe, and you know things are starting to be fun straight away if I'm using unsafe. Not only unsafe, I'm going to use unsafe as, which is actually a very interesting method that one of its use cases is what you're going to see here. But if you want to see a video on unsafe.as, it's just mind-boggling how many things you can do with it. So just leave a comment down below. And I'm sure those of you who know how insane it can actually get will say, no, don't do it. That's actually going to be bad for the viewers. I think it's fun. So I'm going to say unsafe as, and I'm going to say user array as immutable array of users. And then I'm just going to pass down a reference to those users. And now, let me show you what we have. I'm going to put a breakpoint here, debug this. So change this back to debug mode and debug it. And as you're going to see now, we have the same 10 users. But if I step over this, we now have an immutable array of 10 users. However, we did not go through the same process. We didn't even touch that at all. And to prove that, I'm going to run a benchmark that uses this approach. Here we go, added the benchmark, turning this into release mode. And let's go ahead and run this and see where we are now. Okay, so results are back, and let's see what we have here with this new method. So just for reference, we have the old stuff here, and here's the new stuff. Less than, obviously, this is way less than a nanosecond. It is just basically super efficient. It's negligible because we just point to that background array. And for that reason, we don't allocate any memory. So it is always going to scale the exact same way, which is just constant. It's always going to be equally as fast, and you're not going to be wasting any memory at all for this specific use case. So that is if you are not using .NET 8. However, in .NET 8, we actually got a way to deal with this problem because it turns out many people have it. And to deal with this, what you can do now is say immutable collection marshal, so immutable collections marshal dot as immutable array. And you can pass a user's array or your array over here without using the ref anymore, meaning it can actually be read-only and so on. And this will actually give you the exact same experience. So for reference, I'm just going to add that benchmark over here as well and go ahead and uncomment it and let it run just to see that it actually performs the exact same way, and that is running in the background. So now we have that option, but also the very interesting thing is that we also have the as array method, which allows you to get the backing array from the immutable array. Now, both of these things can be pretty dangerous if you're not very careful in terms of who can actually access those two things, but know they're there and know that they can actually heavily improve your application's performance if you're using a lot of that stuff. Now, just to quickly show you how both things work behind the scenes, if I go to as immutable array, all it's really doing is it's actually giving you access to that internal constructor, and it's just using that array as a parameter there. And the same thing with the as array version. If I go here and I say as array, all it's really doing is it giving you access to that internal backing array that stores the values for your immutable array. So just pretty neat. Let's just wait for this to actually finish now and see how all three compare. All right, so results are back. And as you can see, we have basically the same performance between the two operations. It's just sort of a reference transfer. And that is it. So if you are using that sort of data construct, then you can now use very carefully this as immutable array or this as array methods of the immutable collections Marshall for your applications to deal with that memory issue. Just be very, very careful, because any mutation on that backing array will actually affect the immutable array, because it's just basically a reference to that backing array. But now I want to know from you, what do you think about this, and have you ever encountered this issue? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding.